So jumping back in on this next one, the first thing that I'm going to do is factor and then kind of go from there. So start by factoring sum to 3 product of 2. So I'll give you a minute to think about it, and using these to guide you, it's going to be 1 and 2. So that's going to factor to x plus 1 times x plus 2. So if I take a look, my common denominator is going to be x plus 1 times x plus 2. Which means I need to multiply this fraction right here by x plus 1, because that's what I'm missing. I already have x plus 2. I need an x plus 1. And I'm going to multiply this other one by x plus 2, because I have x plus 1, but I need x plus 2. Okay, remember in the denominator, I could leave it in the factored form, but in the numerator, I'm going to distribute everything out, just like I did on the problem before. It was just distributing an x to everything. So taking a look at this first one, that's just going to stay exactly as what it was, x minus 1 all over x plus 1 times x plus 2 plus, well, I did x plus 2 times x plus 1, which is the same thing as x plus 1 times x plus 2, or x plus 2 times x plus 1. Doesn't matter, those are the same. And my numerator, distributing that 2x, I'm going to end up with 2x squared plus 2x, because 2x times 1 is 2x, equals, my denominator is x plus 1 times x plus 2, and I'm going to leave it just like that in factored form. But in order for me to solve this, I'm going to have to distribute everything in the numerator. So x times x would give me x squared. X times 2 is going to give me 2x. Negative 1 times x would be negative x, and negative 1 times 2 is negative 2. And I could clean up that middle part because 2x minus x is just 1x, like that. Now that I have the same denominator, so going back to our steps, I factored it, yep. I got my least common denominator, distributed everything. Now that they all have the same denominator, now I can just solve the numerator. So I'm just going to look at my numerator now, and that's my equation to solve. So x minus 1 plus 2x squared plus 2x, combining like terms, 2x and x would be 3x. So I have 2x squared plus 3x minus 1 equals x squared plus x minus 2. In order for me to solve quadratics, remember I could graph them, completing the square, factoring, quadratic formula. I'm going to set this equal to 0. So I'm going to move everything on the right side over to the left side by doing the opposite. And once I've done all of that, it cleans up to be x squared plus 2x plus 1 equals 0. So now I have to ask myself, what are some numbers that add to give me 2 but multiply to give me 1? Well, my only options are 1 and 1. So my answer is going to be x plus 1 times x plus 1, or x plus 1 squared, equals 0. So when I solve this, I get that x equals negative 1. So going back and taking a look, if I plug in negative 1, I'm just right here noticing if I plug in negative 1 right there, I get negative 1 plus 1 equals 0. And you can't have 0 in the denominator, which means that if I plug negative 1 in, I get an undefined answer because I have 0 in the denominator. So this problem actually doesn't have a solution. And that's why it's so important to check it, because if you hadn't checked those restrictions or plugged it in, you would say x is negative 1, but actually there's no solution in this problem. Okay, taking a look at this next one, I need a common denominator. I have x plus 2x minus 2, so I'm going to make that common denominator x plus 2 times x minus 2. So that means for my 1, I can replace that 1. Remember, 1 is the same thing as 1 over 1. So I just need the same thing in the numerator and the denominator. So I'm just going to change that to x plus 2 times x minus 2 over x plus 2 times x minus 2. I'm just using my common denominator. And remember, 7 over 7 is just 1. 8 over 8, that's about 8. It's just 1. X over x is just 1. So x plus 2 over x minus 2 over the same thing is just 1. But then I need to multiply because this needs an x minus 2 on the top and on the bottom. This needs an x plus 2 on the top and on the bottom. And I'm going to start distributing everything out. So 2 times x minus 2 is going to be 2x minus 4 all over x plus 2 times x minus 2 plus x times x plus 2 is x squared plus 2x all over x plus 2 times x minus 2, which equaled 1, which was x plus 2 times x minus 2 all over x plus 2 times x minus 2. And now that I have that common denominator, I'm just going to look at my numerator. And I'm actually going to go ahead and distribute this out. So x plus 2 times x minus 2 is just a difference of squares. So if I distribute everything, I'm going to end up with x squared minus 4. Going backwards, square root, plus minus, it works out. So this is what I'm looking at. So x squared plus 2x plus this over there would be x squared plus 4x minus 4 equals x squared minus 4. Subtract x squared, and I end up with 0. And then I have 4x minus 4 equals negative 4. So this isn't even a quadratic anymore. And once I start solving it, so 4x equals 0, divide both sides by 4, x is 0. Which, remember, you can't have 0 in the denominator, but 0 might actually work out as a solution. So when I go to check this, plugging it back into my original, 2 over x is 0 plus 2. 0 plus 2 is 2, so 2 over 2 is 1, plus x over x minus 2. Well, if I plug in a 0, 0 over 0 minus 2, 0 minus 2 is negative 2. 0 over negative 2 is just 0. 1 plus 0 is 1. So my solution works out. So as you can see on some of these problems, we had no solution. Sometimes we had one solution. Sometimes we had two solutions. But it always starts out by factoring, find that common denominator, and once you have that common denominator, solve for your numerator. And life is a little bit nicer when you have proportions and you could just cross multiply, or if you already have the same denominator and you have to solve. And that's how you solve rational equations.